We are in the process of learning about pointers in C in our series of C programming lectures. In this lecture, we are going to talk about character pointer and function. Before we begin, let's see what we are going to cover in this lecture. We are going to broadly cover 4 different topics. First of all, we are going to see what is string, constant, and a pointer. Then we are going to see string pointer versus string. What is the difference between string pointer and string? We're going to write a program to demonstrate this as well. Then finally, we're going to write our own function to perform string copy operation. First of all, using the array notation. Then we're going to improve that program. We're going to write the same program, that is to perform string copy using the pointer notation. Okay, so let's get started. Now, first of all, have you seen a string constant? What comes in your mind whenever I say string constant? Like, for example, if I tell you, if I just write 1, what is this? You say this is an integer constant, right? Similarly, you have already encountered in many of the previous programs, whenever we write text inside double quotes, it becomes a string constant. Okay, like in this example, you see hello is a string constant because it is enclosed within double quotes, right? Now you have seen this kind of a statement many times in a program. We have already discussed this while discussing in the unit strings, right? But you have seen this very frequently in a printf statement like this, right? In a printf, we write double quotes and the text that we would like to print. So in this example, I have written printf double quotes hello and printf is closed here, right? So whenever I do this, what happens is hello is displayed in the string. Now you see, whenever I write printf hello, now what is this? Let's focus on this hello, which is there in double quotes. Now how is this stored in the memory, right? This is a string constant. Okay, so it's a string constant. String is what? String is collection of characters, right? So hello will occupy a space in the memory. So let's say how many space, what is the length of this string hello? The length here is 5 because there are 5 characters that are visible to you, HELLO, but really it is going to occupy 6 memory locations or 6 different cells, or you can say 6 bytes, because each character takes 1 byte. Why 6 bytes? Because 1 byte will have 2. The last byte of any string would be a null character. We have already discussed this, right? So in the memory, it is going to occupy 6 bytes. Okay, so 6 cells starting from index 0 to index 5. At index 0 you will have H, at index 1 you will have E, at index 2 L, at index 3 also L, and index 4 O, and at the last index 5 you have a null character. Null character is \0. Okay, now because each of these memory cells is going to have a unique address, let's say the starting address is 1000. So each character will take 1 byte, exactly 1 byte. So H will take 1 byte. Let's say it's there in the address 1000. Because it's an array, at 1001 E would be stored. At 1002 the next byte L, 1003 the next byte one more L, 1004 you have O, and at the address 1005 you have the null character, right? Now whenever I write printf, right? So the printf, what is the syntax? What generally printf takes? What should come here in printf? Okay, it should actually have the starting address of the string that you are trying to print. Okay, so starting address of this string is 1000, right? So starting address of this string is 1000. So whenever I write hello in double quotes inside printf, it is going to be translated as a starting address of that particular string hello. Okay, so in this case the starting address is 1000. Okay, so let's say what I do now is, let's say I create one pointer, right? Char star mystr. I create this pointer mystr. Okay, so mystr is a pointer, and I'm trying to store hello in that. Is it allowed? Right? Whenever I write hello, as I've told you in the right hand side, you just look at this, right? I've told you it's a string constant, right? So it is going to have a base address, starting address. So in this example, the base address is 1000, right? So whenever I write char star mystr, so mystr is a pointer that can hold the address of a character, right? And 1000 is the address, starting address of that string. That's the address of the first character H, or the base address of the string. So mystr would now be 1000, right? So I say my str is pointing to this particular block of memory which is starting at address 1000, and it is having the string hello stored in it, okay, in a subsequent memory locations one by one. Okay, now I have told you already that printf, if I write printf hello, I told you this hello would be translated as the base address, starting address of the string, right? So now can I write printf mystr, because mystr is also the base address, starting address of the string, right? Let's see, here I've done printf mystr. Does it work or not? Let's try to demonstrate the same using a program. Okay, so what you do is I write, first of all I write printf hello, right? So this is a very simple statement. I'm printing hello in the screen. Here I told you this, that this hello in the double quotes is what? It's a string constant, right? And this hello, that is the string constant, is treated as a pointer, right? It's the address of the, it's treated as a pointer because is going to have the address of the first memory location of this string hello, right? So hello is treated as a pointer, so it's the address of first char in the string, okay, in the string. Fine. Now let's try to do this. Now if I create one, mystr is a pointer. What kind of a pointer? It's a character pointer because I've written char star mystr. Okay, so it can hold the address of a character, right? Now what I do is, if I make this like, store the string hello, right, equals to hello, right? I have told you that hello itself is nothing. Inside the double quote it is treated as the pointer, right? The base address of this particular array would be there in this hello whenever I write in double quotes. So that would be stored in mystr. Now the question really is, if I write printf mystr just like this, without double quotes, anything, just like this, will it work or not? This is the question, right? So in the first printf, let me also give a new line, okay, and see if this works or not. Okay, so let's try to first of all compile this code. Okay, let's compile this code, gcc char pointer.c. okay, compilation is successful. Just run this code and you see I get hello 2 times. The first hello is coming from this printf in line number 7. That works perfectly well. And the next hello is coming from the printf in line number 14, right? Here I just given mystr. Mystr is nothing but the starting address of hello, right? So it works fine. Okay, so printf generally takes the starting address of the string that you are supposed to print. Okay, so the argument in printf is what? The starting address of the string to be printed. Okay, so the argument in the printf, the argument in the printf is nothing but the starting address of the string to be printed. Therefore it works fine. Now let's discuss a little bit about string versus string pointer. So if you look at this statement here, I write char mystr1, I write subscript, I do not give the size here. If I do not give the size, the compiler will automatically assign the size for me, because in the right hand side I'm assigning the string constant hello to the array of characters mystr1, because hello has how many characters? 5 characters, hello, and one more character for the null, right? Null character. So 6 bytes would be allocated for mystr, right? Whose size now would be 6. Okay, now this is simply a array, right? It's simply an array because I've used the subscript notation here. Now mystr1 is an array. Okay, now how does this look like is very simple. If it's an array, hello would be stored in a contiguous memory one after another. Also the null character would be stored, right? So hello and null character together would be in that particular block, and mystr1 would contain the address of the first memory location of that particular block. This is how the array is interpreted. Okay, like for example, if I write here, it will be like this: H E L L O and the null character like this. Okay, this is the entire array. Okay, and so this is the starting address. Let it be 1000. This is 1001 and so on and so forth. Okay, index started from 0, 1, 2, 3, 4 and 5. Right, now I call this is nothing but my str1. Okay, so my str1 is nothing but as good as the base address of this particular array. Okay, I've told array name itself is a pointer, so I can say my str1 is a pointer. Okay, now let's look at the string pointer. Okay, now in the second example that we have already written down in our code as well, what I've done is in the right hand side I have this hello string constant in double quotes. In the left hand side I'm assigning the base address of this particular string constant to my str2. Now what is the difference between the first one and the second one? The first one is it's really an array, right? The second one is what? It's the pointer. My str2 is a pointer. Okay, so my str2 would contain the address of the first the base address of the particular string constant hello, right? So if pictorially if you see, hello is there, right, and my str2 would contain the address of hello. So my str2 is actually pointing to this string constant hello. So let's say the starting address here is 1000. So 1000 is stored in my str2, right? So the difference here is only that my str1 is interpreted as an array and my str2 is interpreted as a pointer, right? But internally, my str1 is also a pointer, right? We have already discussed that array name itself is a pointer, but while interpreting in the program, it will be interpreted as a array for the first case, my str1 as a pointer in the second case. To demonstrate this point, let's try to write one program and see how it behaves. So here, first of all, let's create an array of characters, or we call it as a string. Okay, so let's write my str1. It's a string. Here let me store the string hello. Right, now let me create one the string or the character pointer char star my str2. Okay, and let me now let this pointer point to the starting address of this particular string constant hello. Right, now we wanted to know what's the difference between my str1 and my str2. Okay, difference between my str1 and my str2. We have told that my str1 is an array and my str2 is a pointer. So let me first of all try to see try displaying both of them first of all. Okay, so let me write my str1 equals to %s. Okay, and let me give a new line. Okay, let me print my str1. Okay, and now let me also print my str2 is, let me print using string using %s format specifier my str2. Okay, do we see any difference if we do it this way? Let's try to compile this code. Okay, and let's try to run this. In both the cases we get this output hello, so we see no difference in this, right? So now let's try to see the size. Okay, let's try to print the size of my str1. Okay, printf size of my str1. Okay, is, because size is an integer, right? How do I get the size of any variable? I have to use size of operator. Size of what? Size of my str1, correct? So this will print the size of the my str1, and let me now copy this and try to print the size of my str2, right? So printf size of my str2. Okay, my str, here after also write my str2. Okay, let's try to compile this code. Okay, and see what really is the output. Okay, I compile this here and then I run it. Okay, now you see size of my str1 is 6 bytes and size of my str2 is 8 bytes. How is it? My str1 is a array that we have told you, right? So why 6 bytes? Because there are 6 characters. HELLO hello 5 characters plus one more character, that is the null character, 6 bytes for 6 character. Therefore the size is 6. But mystr2 is nothing but a pointer. It's not an array, it's a pointer. So pointer in my machine is occupying 8 bytes, right? Each pointer is occupying 8 bytes of memory space, right? So therefore it is taking 8 bytes. Okay, now let's try to add some more text to this. Let me make this as hello world. Let me also make this as hello world, right? If mystr2 is a pointer, then it's still, because pointer will take 8 bytes, right? So it will still be 8 bytes. But mystr1, now how many characters are there? 1 2 3 4 5 6 7 8 9 10 11 plus null character, 12 characters. So I should get 12 and 8 as the output. Let's see what happens in this case, right? Correct, I see 12 bytes for mystr1 and 8 bytes for mystr2. Even you can try to print, like let's say I can also do this way, right? I can create one integer pointer, okay, int star p, okay, and let me print the size of this. Okay, I can just write this and see what is the size of integer pointer. It should again be 8 bytes, because pointer would always take 8 bytes in my machine. In your machine it can be different as well. Okay, size of p, okay, size of p. Let's try to run and see what is the size of integer pointer, right? See, size of integer pointer is also 8 byte. So now we can conclude that mystr2 is a pointer and mystr is treated as an array, although internally it is also a pointer, right? But it is treated as an array. mystr2 is a pointer. Okay, so this is the difference between the array and the string pointer, or the pointer to the string constant. Okay, so this is the difference. Okay, now we're going to write a function to perform string copy. First of all, let's do it using the array version. Okay, then we're going to improvise the program to write the pointer version to do the string copy. Now if string copy needs to be implemented, right, we are supposed to write the function. So if string copy is a function, right, it will be taking some input, right? String copy is what? Copying one string to another string. So I'll have the source string would be copied to the destination string. So I'll be needing two parameters in this case, two arguments or two inputs. One is the source string, right? Source string, I'll just write source. Another one is the destination string, right? So the logic is I'll have to copy the source string, the content of the source string, to the destination string. So I really return nothing, but I'll perform the copying, right? I'll have to perform the copy. I'll copy the source string content to the destination string. Okay, now let's try to see the logic for this. We have already covered the entire logic for string copy in one of our lectures in the string chapter, right? I'll put the link of that video in my description, but let's just quickly discuss the logic here as well, right? So let's say I have this character s, which is the source string. Maximum it can hold 10 characters. Here hello is stored, right? And so this is how it looks like. The box is created, hello is stored, index is starting from 0 to 5. At the last there is a null character. Now let me create one more a character array d, maximum size is 10, right? So this is a destination string starting from index 0 to index 9. I have only stored up to index 5. Okay, now my job is to copy all the content of this source string to the destination string. What would be the logic, right? So I'll keep on copying the contents one by one to the corresponding index. So index 0 content, index 0 value would be there in index 0 of the destination string. So here I have to get h, right? Here I'll have to get e. So I'll have to keep on copying this until I reach the null character, right? So the logic is while, okay, if in my source string, let's say the index is I, so initially let's say I is 0. Okay, this is just an algorithm, is not equals to null. If it is not null, what do? I'll copy the source string at index I to the destination string. Okay, so S0 is copied to D0, then S1 is copied to D1, S2 is copied to D2, S3 is copied to D3, right? S4 is copied to D4. That's all, because now I reach the null character, I'll stop, Okay, at the end of the loop, what I do is I'll have to make sure that in my destination string at index I, which is now 5, okay, also one more thing, I have to increment the I here in the loop, because each time I should be incremented, otherwise I'll not be able to advance in my the array, right? So, and finally at the last index, that is I, I'll have to make the null character. This logic I have already discussed previously, so I didn't discuss it in more details. If you want to understand the logic really well, go to the video in the description. Okay, you will understand it better there. So let's try to implement this first of all using the array notation and then using the pointer notation. So here I'll write my code to perform string copy, first using array notation and then using the pointer notation. Okay, so first of all, let's create some strings. So let me create the character array. So source is S. Let the size be 10 for now. Okay, and let it store hello. Source is storing hello. Let me create a destination D, okay, which is having the maximum size of 10, okay, and it is having nothing right now. Okay, so my job is to copy source to the destination, right? So I'll have to do that using a function, right? So if I have to do that using a function, the function should have 2 arguments, right? So I'll just write void string copy. Let this be the name of the function, okay, and the first argument is, let's say you can put it as the destination, right? So char D, so this is destination, and char S is the source. Okay, so here the dimension is not required. Okay, so you can skip this. If you give the dimension, there is no issue. Okay, now, or you can rename this also, like, you know, dest for destination and source, like you'll write it as SOURC source. Okay, there's no issue in this. Now let's write some code here to do the string copy. So for running a loop, I'll be needing the index I, right? So I'll just write, initially I is what? Initially I'll have to start with index 0, right? So I'll just write while in my source string at index I see if the content is not equals to null. If the content is not null, what do? I'll have to repeat copying, right? So I'll have to repeat copying. What do I copy? I'll copy in the destination string dest I at index I. I'll copy the content from the sources string at index I, and then for the next iteration I'll have to update the value of I. Next index would be 1 now, right? So I'll have to update the index, and at the end, once everything is done, I'll have to ensure that in my destination index at index I, now that is the last index, I'll have to put the null character. Okay, so this is the entire logic for performing string copy. Okay, so here I'm taking the array as the input, so it will be making the changes in the main function itself. So we need not worry whether it's going to make the changes in the main function, because we are going to pass this destination from the main function. Okay, so here we'll write string copy. So first of all destination and then source. Okay, so it will pass the base address of this destination array and base address of this source array to the string copy function, and now here the copy operation is done. So therefore it is actually, because it is passing the address or the pointer, so it is going to make the changes really in these locations. So finally the copying should be done. So let me try to print destination string is %s, okay, and let me just write D for the destination string. Okay, so this is a simple program to perform string copy using a pointer. We have already done this program. This is just a revision. I'm going to compile this code. So there's some errors I'm getting or warnings I'm getting. Let me see what is this. Printf. Okay, so maybe some spelling mistake in printf I've done. It's printf printf. Okay, I hope header files are given. Yes. Okay, so let's try to compile it again and see if it works fine. Yeah, there's no error now. So let's try to run this code. So you see destination string now is hello, right? Now can we modify this a little bit? Can we make this work using the string notation and not using the array notation here? So not string notation, we are going to use the pointer notation. Can we use this or make this or revise this program so that it works with the pointer notation, right? So if it has to work with the pointer notation, what I have to do is let me create a pointer here. So instead of creating this s, let me create because source is not modified, right? It's a string constant. So hello string constant, I'm putting the base address of the string constant in the pointer s. Okay, and the destination, let d be the destination, what do you say, array. Okay, now what I do is let me just do it like this. Okay, so here instead of doing this, let me take the destination as int star d. This is the destination pointer, this is the pointer to the source string. Okay, so what I do is instead of writing source I'll have to write star s plus I. This you have already learned while we have discussed array and pointers. Okay, so if you have any doubts in this, you have to go to that video. dsti can be written as star of d plus I, and source I can be written as star of s plus I. Okay, each time I increment I, and finally at the last index star d plus I, what I do is I'll put the null character, right? And then I think I'm done. Okay, so let's try to compile this code and see if it works well. Okay, compilation is successful. Run it, I get the destination. Copying is done now. Okay, this is how string copy works. Now what we'll do here is we'll try to modify this program a little bit, okay, so that we can improve this. So the idea is because we are working with string, right? So we did not actually have this index I. Okay, so because we already have this string, we can directly copy the content from the string directly, because you have got the address of those strings, and then we can increment the pointer itself. Okay, so let's get rid of this index I first of all. Okay, and let's do if while star s would give me what? The content that pointer is pointing to. So initially s is the pointer to the first location of that string. So star s would be the first content, really the first content, the first character in that particular string, right? If it's not null, what do I do is I'll simply write star d at the first location. I'll copy star s, and now for the next iteration I'll have to increment the pointer. So I just write s plus plus, right, and d plus plus. So if I increment s, if I do s plus plus, if s was 1000, for the next iteration it will be 1001, which is the address of the next character in the string. Similarly, d plus plus would be the place where I'll have to place the next character. Okay, so if I do this, I think our job is done. So at the end, star d is the location, the last location. I have to put the null character. So let's try to do this way. If you are confused with this, the previous one is also all right. That is working fine. Okay, so compilation is successful. Let's try to execute this. See, you see hello, right? So you can change this hello and make it like, let's say hello India. Okay, so let's try to compile this code and then run. It works really fine. Okay, so more or less we have now covered this. Okay, so the idea for this lecture was how we can actually write a program wherein we can pass the string or the string pointer as an argument to a function like this, and how string pointer really works, right? What is a string pointer? What is the array, the difference between the array and the string pointer, right? How does this string copy works? We have done both the array notation as well as the pointer notation. So with this note, we are done with this particular lecture. Okay, this completes this section wherein we were covering about pointers, right? So there are more advanced topics and pointers which will be coming up as a separate chapter in the later videos, but this is what is going to be the end for this particular chapter number 15, unit number 15 on pointers. Now next unit would be on structures and union. Okay, so that is unit number 16 would be a structure and union. And then later on we are going to also cover more advanced topics on pointers, where you will be getting 4 or 5 more lectures on pointers. Okay, so until then, stay tuned.